Hello, in this video, let me talk about activation functions for neural networks. Activation functions produce a nonlinear transformation of the input data. Usually, you're going to find at least these three activation functions. A sigmoid function, and then a tanh function, or hyperbolic tangent function, or ReLU function, rectified linear unit function. Okay. Sigmoid function is 1 over 1 plus e to the power of minus x, okay? And the tanh is a e to the x power minus e to the negative x power and divided by e to the x power plus e to the negative x power, okay? And the ReLU is relatively simple. When x is negative or 0, and then fx is 0, otherwise it has the same value as the input. Okay. If you remember the conceptual part of neural network, as you can see over here we have at least two parts of data transformation. So over here we basically add all this input data using a weight. Okay, so we multiply each input data by the weight and we do the summation. And then by applying a nonlinear activation function, we produce the output. Okay. All right. So even though these activation functions take a lot of time to calculate, we have simple functions that you can actually use. So let me show you how they look like. Okay. So let me explain this code to generate the plus. Okay. So basically, it's going to look like this. Okay. So we use pyplot from a matplotlib and a numpy. Okay. And then we get the x values. Okay. If you remember linspace, let me show you. So linspace return evenly spaced numbers over a specified interval. Okay. And then from -3 to 3, we get 100 values. And then we're going to make a plot for the sigmoid. Okay. That's 1 over 1 plus e to the negative power, exactly like this. In case of a tanh, there is actually a function available in a numpy, so we can just use that, np.tanh xvals, okay, tanh. And in case of a ReLU, we can have a simple maximum function, whichever is great, between xvals and 0, okay. Then we put a legend to the upper left, like this, okay, and the y, this axis, from -1 to 1.5, okay, -1 to 1.5, and then a x label, x, okay, and then a y label. We have 3 values from sigmoid, tanh, and then ReLU, okay. All right, so let's take a look at this one using the larger plus. Okay, let me make a copy this plus and to a Word file. Okay, no, not this one, this one. Okay, so as you can see over here, both sigmoid function and then a tanh function, they produce S curve. They produce S curve. Okay. In case of a sigmoid function, those values fall between 0 and 1, okay? Somewhere between 0 and 1, okay? In case of tanh, tanh function values are somewhere between -1 to 1. You see that? -1 to 1. They get close to 1, they get close to -1 as the numbers go larger and larger, or smaller and smaller. Okay. In case of a ReLU, up until the x is 0, it's going to be flat, just 0. Okay. And from 0, and then the value, ReLU function value, will be the same as the input value. Okay. When you use Python for neural network implementations, we have at least these two classes you can use. MLP regressor for the numerical predictions or regression, and MLP classifier for classifications. Okay. By the way, MLP stands for multi-layer perceptron. Okay. For these two classes, the ReLU is the default value. So unless you change the parameter value for activation function, it's going to be ReLU. Okay. Of course, you can change it, and you can actually compare the performance of your model between a ReLU, TANH, or the sigmoid. Okay. All right.